Hello all. In this video, we will take an example of single phase AC circuit, which is nothing but a series RL circuit, and we have to calculate the quantities. So before starting the video, please subscribe my channel, like the video and share to your friends. So in this numerical, a coil of resistance 12 ohm and an inductance of 0.1 Henry is connected across a 100 volt 50 hertz supply. Then calculate. Okay. So ये जो फिगर है ये हमको बनाना होगा. I have drawn the figure from the question. Okay. Question दिया रहेगा. So a coil is here. 0.1 हेनरी इसका इंडक्टेंस है और इसी कॉइल का ही रेजिस्टेंस 12 ओम है जो उसको हमने सेपरेट यहां से बना के रखा है. ओके, मींस ये कॉइल का ही रेजिस्टेंस है, उसको सिर्फ सेपरेट यहां पे शो किया गया है. ओके, एंड द क्वांटिटीज, एंड इट इज कनेक्टेड टू 100 वोल्ट 50 हर्ट्ज AC supply. So we have to calculate reactance and impedance of the coil. Okay, current, phase difference, power factor. Okay, let us start. Reactance, we know here only inductance is present, so the reactance is only inductive reactance, which is nothing but XL. Okay, and this XL is equal to, we know the formula, 2 pi F and L, where pi is, we all know the value is 3.14, frequency given is 50 hertz, and the inductance given is 0.1 Henry. So this is the formula of inductive reactance. This reactance is nothing but the opposition offered by the inductance to the change in current. We know the property of inductor, it opposes the change in current. So this property is written as XL, which is inductive reactance, and the unit of XL is ohm. Here the unit of L is Henry, but the unit of XL is always in ohms. So put the values. By putting the values, XL is equal to 2 into 3.14, which is pi, frequency given is 50 hertz, and inductance given is 0.1. Okay, so it is XL. After calculation, the result obtained is XL is equal to 31.416, and I have already told the unit is in ohms. Okay, so it is our first answer. It is what? Reactance. Reactance means inductive reactance. There are two types of reactances in AC circuit exist: inductive reactance and capacitive reactance. But in this question, only inductor is given, so it will be only inductive reactance. Now, moving ahead, we know Z. Z is impedance, okay, and the formula is under root of r square प्लस एक्सएल माइनस एक्सी का होल स्क्वायर. ओके, सो आर स्क्वायर प्लस एक्स एक्सएल माइनस एक्स सी होल स्क्वायर. Okay, now in this formula we know there is no any capacitor, so xc is 0, so the formula will be under root of r square plus xl square. So the value of z is equal to simply under root of r square plus xl square. So where r is what? It is given as 12 ohm. So r square plus XL we have calculated 31.416 का square. Okay, so the formula of impedance is under root of r square plus XL square. The value is, after calculation we got the value z is equal to 33.63 ohm. Okay, so it is our second answer. Z, it is our second answer. Now current I, current I is equal to, we know, it is simply V by Z in AC circuits. So we know I is equal to, V is 100 volt and Z is 33.63. The value km is 2.97 amperes. So it is our next answer. Now, phase difference, we know a formula tan phi is equal to x by r. Tan phi is equal to x by r from power triangle. So phi is equal to tan here I have to draw it, tan inverse XL by r. Okay, so the angle came out to be 69.1 degree. Sixty 9.1. 1 degree, it is the value of phase angle. Okay, we can also get this phase angle from the formula of power factor. Cos phi is equal to R by Z. Okay, so phi is equal to cos inverse R by Z. Now power factor cos phi came out, power factor is equal to cos of phi it is equal to 0.3568, 0.3568. Okay, so it is power factor. We can also draw the phasor diagram in this case, the phasor diagram of this figure. Okay, so you can note down this. Further we will draw the phasor diagram. So I am removing all this. Now we will draw phasor diagram. Okay, so one line I took as a reference. It is a reference. Okay, and it is current I. It is I. We know for resistive drop, means this resistive drop, VR is in phase with this I. VR is voltage across resistor. Okay, it is given by IR. So this voltage I into R is in phase with this current. We know voltage drop across inductor is 90 degree out of phase. Okay, and in inductor current lags, so voltage leads, इसीलिए ऊपर बनाया. So it is what? I into X L. Okay, here it is simple. Now by law of parallelogram, or we can say resultant, so we will draw a line parallel to this line is parallel to this, and one line parallel to IR. Okay, so this is the vector sum or the vector equivalent. So it is I into this value is this phasor is I into Z. Okay, this phasor is I into Z. Here it is. I Z. Okay. Now this is the voltage V, this is voltage V, and this is current. This is total voltage V, and this is total current I. So the angle between voltage and current is what? Phase angle. So here it is phi. Okay. Here it is phi, because phi is the angle between total voltage and total current phasor. Okay. So it is total voltage and it is total current. Okay. So the angle between these two is phi and it is power factor. Okay, you can ask me any queries in the comment box. Please like, subscribe the channel. Thank you very much.